Hello, I am Areen Arabiat, one of the authors of this paper. This video will present the main issues of our paper, which is titled Driving Behavior Analytics and Intelligence System Based on Machine Learning and Data Mining Techniques. The first author, Areen Arabiat, master degree in ITS Engineering, Intelligent Transportation System. She is lab supervisor and part-time lecturer in Department of Communication and Computer Engineering at Al Ahliya Amman University. The second author, Muneera Tayeb. She has master degree in Communication Engineering, lecturer. She is lecturer in Department of Communication and Computer Engineering at Al Ahliya Amman University. The outline of our presentation includes introduction, lecture review, novelty, methodology, which consists of proposed model, data set, and classification methods. Results, conclusion, future work. As you know, one of the most causes of road accidents is driver behavior. To reduce abnormal driver behavior, it must be detected early on. Previous researchers had demonstrated that drivers' performance is affected by behavioral and physiological indicators. So the goal of our study is to classify the driver behavior in three classes. The first class, aggressive, if the drivers have sudden left or right turns, accelerating and braking. The second class is normal, if the driver has average driving events. The last and the third class is slow, if the drivers are keeping a lower than average speed. Also, in introduction, we talked about the application of artificial intelligence and machine learning and deep learning, which are strong technologies that employed in very various setting and application. Also, we can, in this introduction, talk about ITS, Intelligent Transportation System, and their application and the prediction of accidents and to avoid any accident by detect any abnormal of driver behavior. Also, in our study, we talked about different studies that were conducted before. In this table, we talk about three of them. The first one in 2020, the model in this study used neural network. The accuracy was between 73% to 98%. The second one which was conducted by Malik and his colleagues. The proposed model consists of random forest support vector machine, Gaussian B-bias, and logistic regression. They used Python in their search. The accuracy was 90%. The third study was conducted in 2022. They use CNN convolution neural network using MATLAB. The accuracy was 99%. And our proposed model, which in our model, we use random forest, AdaBoost, and CN2 rule inducer using Orange 3 data mining tool. The accuracy was 100%. The novelty in our study, we use registered data set from Kaggle. It consists of 3,084 instances. Also, we use Orange 3 data mining tool with a combination. Orange 3 is a data mining tool as a visual, consists of Python application. It can treat any data depending on the constructed model. Methodology. The proposed model in our research consists of three machine learning or classifier, consists of AdaBoost, CN2, rule inducer, and random forest. The data must be in CSV file format to be fed into the model. Also, the data must be divided into uh, parts, training and testing. Training must be around 70% for training the model, and the rest of the data, which is 30%, must is used to testing the model and to validate the result. Also, we use 10-fold cross-validation to avoid overfitting. The next figures will show our models using flowcharts and Orange 3. As you see here, the data is collecting from Kaggle. We cleaning the data and data pre-processing. Uh, the data after pre-processing, all features must be fed to Orange. Then, after building the model, the classification using a random forest, AdaBoost, Centuro, and Inducer. Then we get the performance matrices evaluation, accuracy, sensitivity, precision of measure. We take then the results as this screen. We can then classify the results according to aggressive, slow, normal. This screen shows the data table. This table shows the number of instances or records, and we have 6 features. This all features that is fed to the Orange 3. This is the model with this test and score. All classifiers are connected to the test and score. This is file data table. There is confusion matrix to find the result. This window shows the confusion matrix. This show the result. Also data table. This table or this windows show the features and this targets aggressive, normal, and slow. The data set, as we talked before, the data set was obtained from Kaggle. It contained different features. The data set includes the 3,084 instances. The main features that is used gravitational acceleration is subtracted. Okay, by take 3 data acceleration was x and y z axis in meter per squared. The data rotation was also x y z axis in degrees per second. The classification label or classes was slow, normal, aggressive. The data was collected using Samsung Galaxy S21. Data processing. The data pre-processing must be cleaning by removing any corrupted or badly or duplicated data to be useful for use in this model. And the data must be any duplicated data must be removed to eliminate unnecessary data from driver behavior prediction system. So after that, we must convert the Excel file to CSV, become a separated file to be compatible with Orange 3 data mining tool. Orange 3 data mining tool is an open source data mining toolkit for exploratory data analysis and visualization. It is based on Python, serves as platform for experiment selection and beneficial when innovation, dependability, or equality are required. Orange may be used on command lines or in any Python environment to provide a well-structured overview of many capabilities. Classification method. In this study, as we talked before, also we use different machine learning and deep learning. Also, we use 10 cross validation, 10-fold cross validation to avoid overfitting. Also, the data in this classification method is separated into um, into categories. The first one, training data set, which is consists of 70% for training and 30% for uh, testing to validate the model. Adaptive, the first one of classification, classification method, adaptive boosting, AdaBoost, is one of the good classification solution. As you know, the AdaBoost weak classifier, which employs weighted majority voting criteria as an ensemble learning techniques that blends weak and strong classifiers. However, it has difficulty with generalization and overfitting. We can also, by this strategy, construct a model by giving equal weight to all data items. The second classifier, C-into rule inducer. The C-into rule inducer is a learning algorithm that is an iterative approach. It can pass across a large number of samples from a single class plus a few additional classes. So it's successful by adding its to rule list. Random forest, the last one of our classification method, it was invented by Breman in 2001. It consists of a huge number of decision tree classification model. It has a great ratio of accuracy because it's a combination of a huge number of decision tree. In this work, the efficiency, according to the results in this work, the efficiency of the proposed model was examined using its measure and accuracy, precision, sensitivity as a result of confusion matrix, as you know. This table provide the performance evaluation matrices for each one: accuracy, sensitivity, precision, if measure. The study of this paper find the accuracy according to the best one of the AdaBoost has accuracy as one, AUC, area under care, the accuracy one, F measure one, as 100%, recall also one, see into inducer in the next, in the second arrangement. It has 99 and 9%, and the random forest is hand 0.995. In conclusion, as you know, road accidents are worldwide problem caused by human driving behavior, resulting in fatalities among the people. So we in this study can invent and provide detection system for driver behavior, for abnormal behavior, reduce any to reduce any risk of driving in the roads. By using this data set from Kaggle and different machine learning classifiers using Orange 3 data mining tool, we can classify and find that the Orange 3 data mining tool generated a confusion matrix to evaluate and compare algorithm performance. The results were discussed also in the previous section, and the AdaBoost algorithm was the best with an accuracy rate of 100 for all matrices, while the accuracy reaches to 99 and 8% for CN2 and around 95.4 for random forests. Future work. It is recommended that future study on driver behavior take into account variety driving scenarios and real-time data from vehicle sensors. Long-term studies for machine and deep learning can improve prediction accuracy through knowledge and can be obtained from behavioral factors such as stress and distractions. Also, the idea's effectiveness is demonstrated by using in real world with driving classes and insurance companies. Additionally, the use of user-friendly softwares promotes safer driving behavior. When adopting new features, it's critical to consider the implication of regularity and ethical concerns. Furthermore, by working with the auto industry, predictive models can be integrated into automobile safety system. Thank you for your time and thank you for your esteemed journal for acceptance of our paper. Thank you.